Hey everyone, and welcome. Today, we're going to dive into something that is absolutely fundamental to MATLAB programming, the big difference between scripts and functions. I'm telling you, once you really get this, it's going to be a total game changer for how you write your code. So let's get into it.
So, let's set the scene. Imagine you're an engineer, and you've got a tricky problem on your desk. It involves a whole bunch of really complex, repetitive calculations. And doing it all by hand? Yeah, not going to happen. It'd be slow, you'd get bored, and you're almost guaranteed to make a mistake somewhere. So, naturally, you turn to MATLAB.
And here's the problem we're going to chew on today. Figuring out a bungee jumper's velocity. We've got the formula, sure, but to get a really accurate answer, we need to run that same calculation over and over and over again for tiny little slices of time. You know, that sounds like a perfect job for a computer.
To solve this, we obviously need an automated solution. We have to find a way to tell MATLAB, hey, you do the heavy lifting for me. And that, my friends, is where programming comes in. And specifically, we're going to use something called an M file.
So what's an M file? Well, think of it like a recipe. It's just a simple text file where you write down all the MATLAB commands you want to run, in order. Instead of typing them one at a time, you can just save this recipe and run the whole thing with a single command. But here's the catch. M files come in two very distinct flavors.
And here they are, script files and function files. Now, at first glance, they might seem pretty similar. But trust me, the way they handle data and interact with your main MATLAB environment, they're worlds apart. Understanding this difference is really what takes you from just dabbling in MATLAB to being a seriously effective programmer.
All right, so let's break it down. We're going to put these two head-to-head, we'll look at what makes each one tick, and more importantly, when you should use one instead of the other.
Okay, this slide right here really gets to the core of it. A script? It's pretty straightforward. It just runs a bunch of commands, and it shares everything, all of its variables, with your main workspace. A function, on the other hand, is more like a self-contained professional-grade tool. You give it specific inputs, it gives you back specific outputs, and, this is the most important part, it keeps all of its internal work private. The real game changer is all about how they handle data.
And that brings us to maybe the most important concept here, variable scope. Here's a good way to think about it. Your main MATLAB workspace, that's like a big public workbench. Anyone can put tools on it, move them around, or pick them up. A function, though, that's like its own private workshop. It brings its own tools in, does a very specific job, and then cleans everything up when it's done.
So, when you run a script, it's like you're working right there on that public workbench. Any variable you make, say G for gravity or M for mass, it just gets left out on the bench. It's still there after the script is finished, which can really clutter up your workspace. Or worse, another script could come along and accidentally change it.
But functions? Oh, they're so much tidier. When you call a function, it takes the inputs you give it into its own private little room. It might create a bunch of temporary variables inside to do its calculations, but as soon as it gives you the final result, it cleans everything up. All those internal variables it used, poof, they're just erased. This is fantastic because it means there's no way it can accidentally mess with what's going on in your main workspace.
So let's zoom in a little closer on exactly how functions pull this off, how they manage all this private, local data. This is really the feature that makes them so incredibly powerful and reliable.
And this example right here, this makes it all click. Check out this adder function. Before we call it, you can see our workspace has variables x, y, and c. Now watch what happens. When we call adder xy, the values from x and y are copied into the function's own private variables, a and b. Inside, it calculates a new c, but, and this is key, it doesn't touch the c that's out in our workspace. Then, after the function is done, look, our workspace is completely unchanged. The function's private little world has vanished. Now you might be thinking, okay, but what if I really need to share a variable between a function and my workspace? Well, there is a kind of backdoor for that. It's the global command. Using it is like creating a special shared locker that both your workspace and specific functions have a key to. It's a powerful tool for sure, but you want to use it sparingly because it can make your code a bit harder to follow.
And speaking of keeping things tidy, you can also organize your code by putting smaller helper functions right inside your main function file. We call these subfunctions. They're basically invisible to everything except the main function in that file, which is just a great way to break a really complex task down into smaller bite-sized pieces without creating a ton of different files.
Okay, so we've got the theory down.
We understand how functions keep our data safe and organized. But what about making them, talk to the user? How do we ask for information or show people our results? That is exactly what this next part is all about.
So MATLAB gives us two super simple but really powerful tools for this. The input function basically pauses your program and says, "Hey user, I need something from you." It waits for you to type something in and hit enter. And disp is its counterpart. It's how the program talks back, displaying a value or a message right there in the command window. It's a perfect little communication loop.
All right, it's time. Let's put everything we've learned together. We are going to build that fully interactive bungee velocity calculator we talked about from scratch. We'll use a function to keep it all clean and self-contained, and we'll use input and display to make it super user-friendly.
We're going to do this in just 4 simple steps. First, we'll declare the function. Then, we'll ask the user for the data we need. After that, we'll do the actual calculation. And finally, we'll display the answer. Let's walk through it.
First things first, we start our M file with that magic word function, and then we give our function a name, freefolly. Now you might be looking at that and thinking, hey, where are the parentheses for the inputs and outputs? Well, we don't need them. This little tool is going to be completely self-sufficient. It's going to get its data directly from the user and display the results right on the screen.
Next up, inside our function, we use that input command 3 times. We write a nice clear prompt asking for the mass, then the drag coefficient, and finally the time. Whatever the user types in gets stored safely in our own local variables, m, cd, and t. And here's the engine of our function. We take that data the user just gave us, which is all tucked away safely in our local variables, and we plug it right into that physics formula we started with. The result of that calculation gets stored in yet another temporary local variable.
And finally, we close the loop. We have to show the user the answer, right? So we use disp to print out a nice clean label, and then another disp to show the final velocity we just calculated. And just like that, our interactive tool is complete.
So let's recap real quick. What are the big takeaways here? Use scripts for simple, quick and dirty tasks where you don't mind if the variables get left in your workspace. But for anything you want to be powerful, reusable, and reliable, functions are your friend. They protect your workspace by keeping all their variables local. And if you want to make them interactive, just combine input and display. So there you have it. You've now got the fundamental building blocks for real programming in MATLAB. You know when to reach for a simple script and when you need to build a powerful interactive function. The only question left is, what problem are you going to solve first?